Here in this video, we are solving a problem to find the minimum attainable pressure of 1 mole of an ideal gas who is following a condition like this: T equal to T naught plus alpha V square, where V is a volume. So, first I shall get an equation for pressure. So, as what is given for you, temperature is T naught plus alpha V square. Let's eliminate this volume and get it in terms of pressure using ideal gas equation PV equal to nRT, but it is given that it is 1 mole, so N equal to 1. From here we can write V as RT by P. Substitute it in this above equation. T becomes T naught plus alpha. V square means RT by P whole square. That is T naught plus alpha R square T square by P square. Let's multiply this equation with P square throughout the equation. What happens then? T P square equal to T naught P square plus alpha R square T square. This P square and multiplied P square will get cancelled. So if I take P square common, T minus T naught equal to alpha R square T square. We can simplify this equation further and write P square as alpha R square T square by T minus T naught. Let's take a square root on both sides. That becomes what? Once if you square root it, what you will get it is square root of alpha. Square root of R square is R. Square root of T square is T by square root of T minus T naught. It is in denominator, so when it comes to the numerator, you will get it as minus half. That's the equation for pressure. You got an equation for pressure. Now we want to put a condition that this pressure has to be minimum. So for a pressure to be minimum, differentiation of that pressure will be automatically equal to 0. So we shall calculate the differentiation of that pressure. Differentiation of pressure with respect to temperature as root alpha R is constant. Differentiation of with respect to temperature, of course. T minus T naught of whole power minus half. This is differentiation of UV formula. Differentiation of UV is U into differentiation of V plus V into differentiation of U. One term has to be kept constant and other term has to be differentiated and vice versa. Let us do that. dP by dt equal to root alpha R constants. Differentiation of this term dt by dt equal to 1 and this term has to remain as it is. So what is that term then? T minus T naught of whole power minus half. You are keeping this term constant and you are differentiating it dt by dt. That is first term. Next time you keep this term constant T and differentiate this d by dt of T minus T naught whole power of minus half. This we have to simplify. Let us simplify this. Root alpha R is constant. This is the same value. I am not changing it in any way. Differentiation of temperature with respect to dt, that is equal to 1 plus T into, we have a formula, differentiation of x power n equal to n into x power n minus 1. That's a standard formula that you know it. Let's apply that. X power n is minus half. So minus half into x n is that. X means T minus T naught. N minus 1. N is minus half and then minus 1. This I have to simplify further. Let us simplify that further and see what do you get it. That implies dp by dt equal to root alpha. R is constant. The first term is t minus t naught whole power of minus half into 1 plus the second term is t minus t naught. This minus half is also there. T and minus half is also there. So let me say minus t by 2. T minus t power whole power of minus 3 by 2. Let us simplify this further. And what we have to say is, for pressure to be minimum, dp by dt has to be equal to 0. Differentiation of that function has to be equal to 0. Let's equate that to 0. This one, that's a differentiation. Root alpha, it's root alpha, r t minus t naught power of minus half plus minus half into t minus t power of minus 3 by 2 equal to 0. This constant, when it goes to the other side, becomes a 0. This is a minus term. If you take it to the other side, it becomes a plus term. Then what happens? T minus t power of minus half equal to, this minus on the other side becomes a plus. Half t minus t naught whole power of minus 3 by 2. Now, half t minus 3 by 2 can be written like t minus t naught power of minus 1, t minus t naught power of minus half. In the powers, if we add minus 1 and minus half is minus 3 by 2. So this side you are having t minus t power of minus half. This side also you are having t minus t power of minus half. Both of them can be automatically cancelled. So what is remaining then? This side t by 2. This is minus 1 on the top. When it comes to the bottom, it becomes automatically t minus t naught. This side, that is equal to 1. So you cross multiply them. T equal to 2t minus 2t naught. Take this t to that side. 2t minus t equal to 2t naught. So t equal to 2t naught. That's the conclusion that you got. So what you understood now is, if T is T naught, pressure is minimum. But you want pressure actually, right? We know the equation for that pressure already. We have already derived an equation for the pressure. In this pressure, if you put T equal to 2T naught, I will get the minimum pressure itself. That's what you want to calculate, right? So let us do that now. Yeah, I will scroll down the page a little so that I'll be able to write the remaining part of that. Let me do that. Yeah, right. I'll scroll down this much. So what I can say, if T equal to T naught, P will be P minimum. We know the equation for the P. We have derived the equation. How much? This is the equation that we have derived. So in that equation number 1, let us say in equation number 1, let us substitute T equal to 2T naught, so that I will get P as P minimum. So what's the equation for the P minimum? Yes, from equation number 1, P minimum is equal to root alpha R, in the place of T, 2T naught. Again, in the place of this T also, we have to write 2T naught minus T naught whole power of minus half. So how much is this? Root sorry, alpha, this is R, root alpha and R. Yeah, 2 T naught, 2 T naught minus T naught is T naught power of minus half. So what's the value that you got now? If you simplify this further, P minimum equal to 2 root alpha R T naught power of, this is 1 and that is minus half. So 2 root alpha R, and every time I am writing this wrong, be careful. 2 root alpha R T naught power of half. That is also square root. So your answer is 2R root of alpha T naught. At that particular value, pressure, at that particular value of temperature, pressure is minimum and the minimum pressure is this much. So the problem though looks like lengthy, it's actually simple. What we have done is, from the given relation, we have first calculated the pressure. From that pressure, we have differentiated it. And for somebody to become minimum, differentiation has to become 0. We have equated that to 0 and we got a temperature relation. We have substituted this relation back in P so that we got a answer. That's what your answer is. Thank you for watching.